So now we're going to be looking at operators in Python. When we say operators, operators are symbols or words that are used to perform operations. These operations can be anything like comparing two values, performing arithmetic operations, and stuff like that. So we'll have the arithmetic operators, we'll have the comparison operators, we'll have logical operators, we'll have membership operators, identity operators, and bitwise operators. So arithmetic operators are used to perform basic arithmetic calculations, things like addition, subtraction, multiplication, and so on. So under arithmetic operators, we'll have the addition, and to perform addition, we use the plus sign for addition. Then for subtraction, we use the minus sign for subtraction. Then we'll have multiplication. Multiplication, we use the asterisk symbol for multiplication. Then we'll have the division. We use the slash, the forward slash for division. And we'll have two types of division. We'll have the integer division, we'll have the true division. So this is the true division. Then we'll have the integer division, which we use the double slash. And then we'll have the modulo operator. Modulo operator is like remainder, so we use the percentage symbol. And then we'll have the exponentiation. Exponentiation is the same thing as raised to power. We use double asterisks. So now let's do some examples. So let's say we'll have this variable. Let's call this num1, and we'll assign it to the value of 4. And then we'll have another variable num2, and we'll assign it to the value of 5. So if you want to perform an addition operation on the two values, you can have something like, let's say, result, and you assign it to num1, and then you use the plus operator for addition, and then you put the num2. So if I want to see the outcome of this, I can say print results. So if I run this code, I'm going to get 9, which is the sum of 5 and 4. So to perform subtraction, I'm going to use the minus sign. So in this case, I'll say result is equal to, I'll say num1 minus num2. So if I print this, I'm going to get 4 minus 5, which is going to give me -1. This is for the subtraction. So let's go ahead and do multiplication. So we can say result is equal to, say, num1 multiplied by, that is the asterisk symbol, by num2. Then we can say print result. If we print the result, we're going to have 4 times 5, which is 20. Then we'll look at the division. So we can have something like, let's say, result is equal to num1, and then provide our slash and put num2. So we'll say print result, we're going to get 0.8. And there's something about this division. If you are using the true division, which is using this a single forward slash, you are going to always get a float. So even if you are performing a perfect division where there is no decimal place, it's still going to give you the outcome with decimal points. So let's look at this. Let's say result is equal to, and we'll say 4 divided by 2. Normally this is supposed to give us 2, But because we're using true division, if we print this result, we're going to get 2.0. Now let's look at the integer division. So let's say integer division. So let's say we'll have result is equal to 4 divided by 2. If we print the result, it's going to give us an integer value, so which is 2. But there's a problem with this kind of division. Let's say we'll have 4 divided by 3, and then we'll run this code again. It's going to give us 1. So in integer division, it will perform the division and it will discard the floats. So it's going to only return to you the integer value and then remove the floats. So you should be very careful when you are using this integer division. Sometimes it might give you outcome that is not correct. Then we're going to look at the modulo. So modulo is a percentage sign. So let's say we have result is equal to, let's say 4, and we'll put the modulo operator and we'll put 2. Modulo is essentially the same thing as remainder. So when we have 4 divided by 2, what is the remainder? That is the outcome that modulo gives us. So if we print this result, we're going to have 0, because if 4 is divided by 2, it will give us 2 without a remainder. So, but what if I change this to 3 and run this code? Is going to give me 1, because 4 divided by 3 will give us 1, remainder 1. The remainder is what the modulo gives us. Now we'll look at the exponentiation. Exponentiation is something as raised to power. So when we have something like result is equal to, let's say 2 raised to power 2, that's exponentiation. So if we print the result, it's going to give us 2 raised to power 2, which is 4. If we change this one to 3, it's going to give us 2 raised to power 3, which is equal to 8. Now we're going to look at the comparison operators. Comparison operators are used to compare two values. Maybe you are trying to check whether this number is greater than the other one or this other one is less than the other one. So that is what comparison operators are used for. So we'll have the greater than, which we use the greater sign symbol, and then we'll have the less than, which we use the less than symbol, and then we'll have the greater than or equal to, and we'll have the greater than sign, and then we'll use the equality sign, and then we'll have the less than or equal to. So we use the less than sign and then put the equality sign. Then we'll have the equality. The equality we use double equality sign. And then lastly, we have the not equality. Not equality, we use the exclamation sign and then put the equality symbol. So now let's do some practice. So let's say we'll have, let's say result is equal to, and then I put 5, and I put greater than sign, and then I put 3. So look at how it works. This is the variable, and this is the equality sign. And what this comparison operator does is that it is evaluating this expression to check whether it is true or false. So it checks, is 5 greater than 3? If 5 is greater than 3, it's going to return true. But if it is not greater than 3, it's going to return false. So if I print result, it's going to give me true. But if I change this to maybe 2 is greater than 3, which is false, if I run this code, it's going to give me false. So now let's get to less than. This works the same way as greater than. So we'll have result is equal to, maybe we'll say 3 is less than 10, which happens to be true. So if we print, the result is going to give us true, which is this. But what if I put 13 here and say 13 is less than 10, which is false, and then we'll run this code, is going to give us false. So we'll look at greater than or equal to. So greater than or equal to, so let's look at this. Result is equal to, we'll say 2 is greater than or equal to 1. This is valid. So if I print result and then run this code, is going to give me true because 2 is greater than 1. But what if I put 2 here and run this code? It still gives me true. The reason is because 2 is equal to 2. So let's look at less than or equal to. So we'll have result is equal to, let's put 3 is less than or equal to 10. So we'll print this result. So this checks, is 3 less than 10? Yes. So if we run this code, it's going to give us true because 3 is less than 10. But if I go ahead and put 10 here, is 10 less than 10? No. But 10 is equal to 10? Yes. So it's going to give us true as the outcome. So which is this. Then we're going to look at the equality operator. The equality operator is used to compare two values to check whether they are equal to each other. So when I have something like result is equal to, and then I say 10 is equal to 10. So keep in mind that when you're using equality, you use double equality sign. So this is an equality. So this is a comparison operator. But if I'm using a single equality sign, I'm actually performing an assignment. So when you want to compare two values for equality, you use double equality sign. So if I run this code and print a result, I'm going to have true because 10 is equal to 10. But if I put 9 here and say that 9 is equal to 10 and run this code, it's going to show me false. Then the same thing works with not equality. Not equality checks if two values are not equal to each other. So when I have result is equal to, and then I say 9 is not equal to 10, this is true. So if I print result, it's going to give me true. But if I change this and say that 10 is not equal to 10, it's going to give me false. So that is for the not equality operator. Then we'll look at the logical operators. So when we talk about logical operators are used to combine two expressions or two values together. You know, it works almost the same way as the truth table. When we're talking about logical operators, we'll have the AND operator, we'll have the OR operator, and then we'll have the NOT operators. So let's do some examples. So when we have something like result is equal to, and I put true and put the AND operator and put true. So what this does is that once you have the AND operator, and then you have an expression that evaluates true at the left, and you have an expression that evaluates true at the right, is going to give you true. So in order for an expression to evaluate to true, it means that the both operands, the left and the right operands, have to evaluate to true. So if you have true and false, you're going to get a false. So let me print this result and see the outcome. So if I print this, it's going to give me true. But if I change this to false, it's going to give me false. If I change this other one again to false, it's going to give me false also. So now let's look at the OR operator. So the OR operator, let's have result is equal to, say, true and true or true. True or true is going to evaluate to true. So if we say print result, is going to give us true. But if I say true or false is going to give us true. So in order for an expression to evaluate to true using the OR operator, at least one of the operands must be true. So the only way that this expression is going to evaluate to false is if I have false or false. So if I say false or false and run this code, it's going to give me false. And then we'll have the NOT operator. The NOT operator is used to negate a Boolean value. So if you have not true becomes false, and if you have not false, it becomes true. So we can have something like print and say not true. So if I run this, it's going to give me false. But if I change this to not false and run this code, it's going to give me true. So now let's give an example using an expression. So let's say we have something like result is equal to, and we'll say 3 is greater than 4 and 4 is greater than 3. We'll say print results. So looking at this expression, this is a compound expression that is being connected by the AND operator. So this expression is going to evaluate false because 3 is not greater than 4. But this one is going to evaluate to true. So when we have false and true, we're going to get false. So if I run this code, I'm going to get false. But what if I say that 5 is greater than 4? Which means that this one is going to evaluate to true, this one is going to evaluate to true. So that if I run this code, it's going to give me true. So we can also do the same thing with the OR. If I put the OR operator here, it's still going to give me true because it is true. But what if I change this and say that 4 is greater than 13? So this one will evaluate to true, this one is going to evaluate to false. But because we have the OR here and we need at least one true to evaluate to true, if we run this code, we're going to get true. So now we're going to move over to membership operator. Membership operator is a way of determining whether a particular item, a particular element is present in a sequence. So let's use a list to give an example. A list is actually a data structure whereby you have items that are enclosed inside of a square bracket separated by comma. So let's say we have this list, I'll call it numbers, and we'll put our square bracket and then we'll put 1, 2, 3, 4, 5. So these are the elements inside of this list. So Assuming you want to find out if a particular number is present in the list, you can use the membership operators. We'll have two membership operators, and they include the in and not in. So now let's demonstrate this. So let's say we have result is equal to, and then we'll say 3 in numbers. So this expression here is trying to check whether this value, whether this number is available in this list. If it's available in this list, it's going to return true. So if I print result and run this code, it's going to give me true because 3 is in the list. If I put 2 here and run it, it's still going to give me true because 2 is in the list. But if I change this to 6 and run this code, it's going to give me false because there is no 6 in the list. So the in works the same way as the not in. So what I need to do is to change it and say not in. So it's just the opposite of the in. So when you say 6 not in numbers, this is true because 6 is not in the list. So if we run this code, it's going to give us true. But what if we change this to 1 and say 1 not in numbers? Of course, 1 is inside the list. So if we run this code, it's going to give us false. Let's look at identity operators. So identity operators are used to check whether two values are exactly the same thing. And we'll have two identity operators. So we'll have the is operator and we'll have the is not operator. So let's look at an example. So let's say we'll have num1 is equal to 5, and then I have num2 is equal to 6. If we say something like result is equal to, and we say num1 is num2, of course num1 and num2 are not equal to each other. They are not the same thing. So if we print result, is going to give us false. But if we say is not is going to give us true. But keep in mind that identity operators are quite different from the comparison operator of equality or not equality. So now we're going to be looking at bitwise operators. Bitwise operators are operators that are used to perform operations at the binary level. So we'll have the bitwise, and the symbol is the pipe symbol. We'll have the bitwise OR, which has the AND symbol. Then we'll have the bitwise XOR, which uses the caret symbol. Then we'll have the bitwise left shift. So this is the symbol for it. So we have the bitwise left shift, and this is the symbol for the bitwise left shift. Then we'll have the bitwise right shift. And then finally we'll have the bitwise not. And this is the symbol. So now we're going to be starting with the bitwise AND. So assuming we'll have these variables, let's say num1 is equal to 5 and num2 is equal to 4, and we'll perform a bitwise AND operation on the two numbers. Let's say we'll have result is equal to num1, and then we'll put our bitwise AND operator and put. So if we print result, we're going to have this outcome, which is 5. But looking at this result, it's difficult for us to actually figure out what really happened. So we're going to introduce the bin function. So let's say we want to find the binary equivalence of 5. We can actually do that by using the bin to convert 5 to the binary equivalent. So we can have something like print, and we'll say bin. The bin or bin is for binary conversion, we'll put 5. So if we run this code, we're going to have 0b to indicate that it's a binary number and 101. So this means that 101 is the same thing as, this means that 5 is the same thing as 101 in binary. So if we are to convert 4 to binary, we'll replace this 5 with 4 and then run it again. Then this is the binary equivalent of 4. So we can have this as 100. So now we're going to perform the bitwise operation, but this time around we are going to convert the results to the binary equivalent. So now I'm going to print out the outcome of the bitwise AND operation. So I'm going to remove this print, and then I can have print, and then I use the bin function, and then I provide results. So that if I run this code, it's going to give me 101. This is the same thing as 5. So look at how the bitwise AND operator works. At any particular position, for instance, this is 1 at this position here. If there is 1 at this position and there is 1 at this position, the outcome is going to be 1. So if there is 1 at this position and there is 1 at this position, the outcome is going to be 1. If there's also 1 at this position and 0 at this position, the outcome is going to be 1. But if there is 0 and 0, the outcome is going to be 0. So looking at the result, we'll have 1 here and we'll have 0 here, which will give us the 1 here. We'll have 0 and 0 here, it's going to give us 0 here, and then we'll have 1 and 1 here, is going to give us 1. So assuming we have something like, maybe let's try something else. Let's say we'll say print, and we'll say bin, and we'll put 6, and then we'll run this code. We're going to see the equivalent, which is 110. So let's replace this with 6, and then I'll put 110 here. So this is 110. So look at how it's going to be interpreted. There is 1 here and there is 0 here. We're going to have 1. There is 1 here, 0 here. There is 0 here and there is 1 here. We're going to have 1. And then there is 1 here and there is 1 here. We're going to have 1. So if I run this code, I'm going to get 111. So that is the result of the bitwise AND operation on the two values. So now we're going to look at the bitwise OR. So now we're going to look at the bitwise OR. So in this case, we're going to have results is equal to, we'll say, num1, and then we use the bitwise OR operator and then provide num2. So if we run this code, we're going to have 4. So I can convert this to a binary and then close this parenthesis here, so that if I run this, I'm going to get 100. So look at how it works in the case of the OR. You are required to have 1 at the same position in both operands for you to be able to get 1. So because there is 1 here and there is 0 here, we're going to have 0. There is 0 here and there is 1 here, we're going to have 0. There is 1 here and there is 1 here, we're going to have 1. And that is the reason why our outcome is 100. Then we're going to look at the bitwise XOR. So we'll have result is equal to have num1, and then we'll put the caret symbol which represents the bitwise XOR and num2. So we're going to print the outcome. So I'll copy this and paste it here. So if I run this code, I'm going to have 1, 1. So look at how the XOR operation works. For any position, the two values must be of opposing values for you to get 1. So if you look at this place, you can see that we'll have 1 at this position, we'll have 0 at this position, which will give us 1. Then the same thing happens here. We'll have 0 here, we'll have 1 here, which will give us 1. And at this position, we'll have 1 and we'll have 1 here. They are not opposing values, and because of that, we're going to get 0. So, and that is the reason why we'll have 1, 1. So we'll have 0, 1, 1. So, which is equivalent to 1, 1. So now we're going to look at the bitwise left shift. So let me comment out these codes and clear my terminal so that we can be able to see better. We're using this operator for the left shift. So let's say we have this variable. So we have num, and we say is equal to 5. And of course, from our previous calculations, the equivalent of 5 in binary is 101. So I'll copy this and put it here. So if I want to perform a bitwise left shift, I can have something like result is equal to, then I provide the number. So num, and then I provide the bitwise left shift operator, and then I provide the number of shifts that I want to perform. So let me put 1. So let me print out and see the outcome. So of course this is going to give us an integer result, so we'll have to convert it to binary. So that if I run this, I'm going to have 1010. So if you see very well, this is padding 0 to the right. So if I want to pad another 0, I can change this to 2 and then run it. You can see there are 2 2s. So you can see there are 2 zeros here. If I want to pad maybe another 0 again, let's say I want to pad 4 zeros, I can put 4 here, and if I run it, you can see the padded zeros. So that is for the left shift. So if I want to do the bitwise right shift, so this works almost as the left shift operator, but instead of padding zeros to the right, it pads 0 to the left and then removes a digit from the right. So let's have something like this. So we can have results is equal to, say, num. So let me comment this out so that it doesn't interfere with our original values. And then we use our right shift operator and we provide the number of shifts that I want to perform. Then I can copy out this and paste it here. So let me run the code and see the outcome. So you can see we now have 1, 0. So what actually happened is that when we are doing the shift, it padded 0 to the left, which is 0, 1, 0, 1, and then removed the last digit from the right. So if I shift it by 2 and run this code, we're going to get only 1. So this means that it padded another 0 here and then removed the last one here, giving us 1. So that is how the bitwise right shift operator works. And then finally, we'll look at the bitwise not operator. So this is also a unary operator. So I can have result is equal to, then I provide the unary not operator and then provide the value. So in this case, let's say I want to perform a bitwise not operation on 5. So if I say print result and run this code, is going to give me -6. If I change this to 7, it's going to give me -8. So that is how the bitwise not operator works. So in the next video, we're going to be looking at control structures.